Hello. I had several questions about this particular problem in 11.1a, and so I just wanted to address it really quickly in this video. And so we have this vaccine. It's meant to be administered to infants around 2 months to prevent certain types of bacterial meningitis. In a randomized double clinical trials of the vaccine, infants were randomly divided into two groups. Subjects in group 1 received the vaccine, while subjects in group 2 received a control vaccine. So we have a vaccine and then what looks like maybe a placebo or a new vaccine and the old vaccine. After the first dose, 105 of 77 subjects in the experimental group experienced fever as a side effect. So what we're going to do is I'm going to put the 105 and the 77 in control group 1 over here, right? So basically what I have is new vaccine. Okay, so here we go. We're going to have type, side effect. Let's do that. Side effect, okay? I'm going to have side effect yes, I had a side effect, and no, I didn't, okay? And then over here, we're going to have the new vaccine, and then we're going to have the control vaccine, okay? Now, I know, right, that 105 out of 77 subjects in the experiment experienced fever as the side effect. So they had the side effect, 107 and 717, 105 and 717. Now this is the total, okay? The total in my sample size, right? 717. So 105 had the side effect. Well, so how many didn't have the side effect? All right, well, let's compute that real quickly, right? So let's do expression, and let's do 717 minus 105, okay? And I click on compute, and that's 612. So I'm going to put the 612 over here, and I'm going to go ahead and delete this column because I want to not be distracted by it later on. All right, perfect. So now we're going to the homework again. And so after the first dose, 73 out of 616 of the subjects in the control group experienced the side effect. So in my control group, 73 out of 616. So I have 73 out of 616. 616. I just want to double check. All right. Now, again, I need to subtract to figure out how many did not have the side effect, right? So 616 minus the 73. These are going to be the people, the infants that didn't have the side effect. So it's going to be 543. So 543. And again, I'm going to go ahead and delete this column just to clean this up a little bit, right? So if you take 105 and 612, you get 517. If you take 73 and 523, you get 617. So now I could do like an actual total over here, right? Total, right? A total that actually had the side effect. So 105 plus 73 is going to be 178 that had the side effect. And then 612 plus 53 is going to be 1155. Okay? Out of all of them, right? So 2 plus 3 is 5. 1 plus 4. Right, there we go. Okay, cool. So let's keep going. All right? Does this evidence suggest that a higher proportion of subjects receiving the new vaccine experienced a side effect? So my alternative hypothesis is going to be greater. Okay? Not greater. Perfect. I know that's going to be greater than. So I'm just kind of trying to keep track of everything. All right? So let's explain why this study is a completely randomized design. The subjects in the study were randomly assigned to treatment, which makes the study a completely randomized design. Most of you are not having trouble with this part. The treatment in the study is the vaccine received by the subject, right? So it's either the new vaccine or the control vaccine. That's the treatment in the study. It has 2 factor levels, okay? It has 2 levels, the new vaccine and the control vaccine, 2 levels, right? What is the response variable in the study? The response variable in the study is whether or not the subject experienced fever, overall proportion of subjects who experience fever. Whether the subject experienced fever or not. That's the response variable. Did you experience fever or not, right? So fever or not, new vaccine, control vaccine. So we have our contingency table. That's the fancy word for it. Right here, have it set up, which is great. Okay, so we're going to check the answer. All right, so what are the null and alternative hypotheses? The null hypothesis is that the amount of fever is the same. That's the status quo. That's the no change hypothesis. The alternative is that the new vaccine actually has a higher rate of fever, a higher proportion of subjects receiving it, the vaccine having fever. So we're going to do that. Perfect. Okay. Nice. All right. Now, this is the part where everyone seems to be asking a question, and I knew that this was coming up. So that is why I set up the table the way that I did. So if you look, we're going to let red balls in the urn represent subject who experienced fever as a side effect. Okay? So red balls are, I had a fever. So this side effect, yes, this is actually the red ball. And the side effect, no, that's the green ball. Okay? And total is just the total number of balls that are going to be in the urn. Okay? So now, the simulation should be designed to assume the null hypothesis. We are testing to see whether it's truly different from the null. We're going to set up the urn, and we're going to use, well, how many red balls do I need? Well, we're pooling this, right? The overall, if you're assuming that the new vaccine and the control vaccine don't make any difference, if they don't make any difference, then the pooled proportion, the total proportion, is what you would expect to see in the null. All right, so I'm going to use 178 red balls, okay, total, and I'm going to use 1,155 green balls, and that's going to give me the total of this down here, the total number in the, oh, now I forgot what the green balls were. The green balls were 1155. All right, so I got 1155. Now, to stimulate group 1, I need to randomly choose how many balls. Well, how many balls did I pick in group 1? In group 1, that's the new vaccine group. How many did I pick? I picked 717. So I need to pick 717 balls from the urn and record the number. To estimate the p-value for the experiment, we would repeat this procedure a bunch of times and record the proportion of balls in which, well, how many showed up? 105. Is 105 likely to happen at random or more? So I need 105. This is simulating, hey, how often am I going to get what happened in group 1? Okay? How often am I going to get in group 1? So this is pooled, and then this is group 1. All right? And so that's why we do it like that. And so I check that, and that's good. Okay. Now, we're going to use the urn sampling applet in StatCrunch to generate 2,000 repetitions to get the p-value, and we're going to use this seed value. So I'm going to open up applet simulation urn. Here we go. Applets, simulation, urn sampling. How many red balls do I need? How many red balls do I need? I need 178 red balls. I need 1,155 green balls. I need to draw 717 balls, and I need the number to be greater than or equal to 105. This matches the new vaccine. How likely is the observation in the new vaccine, given the pooled observation, if nothing is different? I'm going to use my fixed seed of 12,641, and I'm going to click on compute. And so now it is set up. And I'm going to go ahead and make this a little bigger. And it says you want to do it 2,000 times. So I'm going to click 1,000, 2,000 runs. You can see here is the proportion in the histogram. And it is about 8%. Almost 9. So I'm going to copy that value right there. And that is my p-value. My estimated p-value is that proportion of samples that I see that were greater than or equal to 105. Okay? And I check my answer. Now, this p-value means that in 1,000 simulations designed assuming the null hypothesis is true, the expected number of cases that are at least as extreme as the study would be about, well, if I multiply that p-value by 1,000, right? So let's go ahead and do that in case we're, right? I'm going to close this out. So data, compute. I have to take that proportion, the 0.088, and I have to multiply it by 1,000. If it had said 2,000 or 10,000, I would have multiplied it by that, okay? So that's why I'm doing it. It's 1,000 simulations. And it's 88. And of course, some of you are like, well, of course it's 88. Well, for some people, we just want to multiply it out, okay? So that's it, rounded to the nearest integer, and that makes us happy. So now, given that our level of significance is 5%, we would not reject the null hypothesis because there is not evidence to conclude that the proportion of subjects receiving the new vaccine that experience fever as a side effect is greater than the proportion of subjects receiving. So this is, I'm not rejecting the null because there is not evidence for the alternative. Okay, I need evidence for the alternative, and I don't have it, and it's greater than, and that's what I tested. And I'm going to check my answer, and that question is done. If you found this helpful, that's great.